Hello, friends. Welcome again to our networking solution center. And in today, we are going to talk about link aggregation. So you're going to understand what link aggregation is, how you can configure link aggregation. So to begin, there's what's called network reliability. Network reliability. Under network reliability is where we are going to have link aggregation, network reliability. Network reliability. And network reliability help us in a situation where maybe there are uh, some links which are gone down, or maybe the device cards has one of the device card has gone down, or the whole device has gone down. So we have to implement redundancy. So network reliability composed of card reliability and card reliability, device reliability, and link aggregation. That is link reliability, link aggregation. Card reliability, device reliability. Link aggregation. So that's what network reliability entails. So card reliability composed of the power modules, the fan modules, and the MPU main processing units and line processing units, also the SFUs. So in this our topic, our main focus will be on link aggregation. So we are going to implement link aggregation through configuration. And so let's just discuss what link aggregation is. So link aggregation is the binding of the physical interfaces into one logical interface. Like for instance here in this our topology, we have got three physical interfaces, gig 1 up to gig 3. The same side here, gig 1 up to gig 3. But now we want to create a logical interface that is going to carry all the physical interface. So the physical interface are going to act as the member interfaces. And in the member interfaces, we are going to consider the priority, we are going to consider the maximum uh, bandwidth number that will be required. So the main reason why we have link aggregation is to increase the bandwidth, so that all these interfaces, they are going to combine their bandwidth and they are going to have an increased bandwidth. Let's say gig 1, its bandwidth plus gig. Let's say if gig 1 has 1 G, and gig 2 also 1 G. So when we combine them, we will all have 3 G. So that's all about link aggregation. That's it's the binding of all logical interfaces, all physical interfaces to one logical interfaces without upgrading the physical device itself. So uh, I can show you something here. Before we come there, in Huawei devices here is the one which I'm going to help you configure. So Huawei always organize ICT competition every year. So this one was an ICT competition of 2019, 2018, 2019 regional final. Uh, I will be helping you to configure the whole practical, as you can see how the practical looks. So the requirement is that the experiment simulates the interconnection between a large and premium size company headquarters and branches. In order to ensure security on campuses, we are going to configure those. So we are going to configure firewall at the end of the session, but in this practical specifically, I wanted to implement only this part of link aggregation. So I only took this part of switch 1 and switch 2. So we are only going to configure this part. Then in our following practicals, we'll proceed with the whole configuration now. Also, uh, uh, there are different modes of link aggregation. So link aggregation mode. So link aggregation modes include manual mode, and LSP mode. So in manual mode, all these three interfaces are going to be forwarding the traffic. But in LSP mode, we are going to have the active and the inactive ones. So let's say if gig 1 and gig 2 are active, gig 3 will act as the inactive. So meaning that in case one of the two interfaces, that is gig 1 and gig 2, goes down, gig 3 should take over the interface that has gone down. There's also something in link aggregation that is called the priority. Priority. We have got different types of priority. So we have got device priority, and also we have got interface priority. Both of these one are important. So the device priority is actually used to select the actor, used to elect the actor. So in switch 1 and switch 2, one of them will act as the actor. Uh, so to select the actor, we always use the device priority. So the one with the lower the priority, the higher uh, uh, the, the higher the selection. It is used to be selected as the actor. So let's say uh, switch 1 here has a priority of 100. Then switch 2 here, we give it a priority of 200. Switch 1 is a priority of 100, switch 2 we give it a priority of 200. But the default priority for Huawei devices, default priority for Huawei devices 32,768. So in a situation where maybe you find that both switch 1 and switch 2, they both have the same priority, like let's say both of them has a priority of 32,768. This one also has a priority of 32,768. That is, both are using the default priority. What we'll use will be now be the MAC address of the device itself. So the smaller the MAC address, that one will use as the actor. So let's say if this one has a smaller MAC address, it will be act as the actor. Then this one will be act as the backup. So now let's now go to interface priority. So interface priority, like this one, these are three interfaces. Like let's say, how will we select the active interface? Like let's say we are told that we have to select two interfaces as the active one, then one of the interface as the uh, inactive interface. So we are going to use what is called interface priority. So the same interface priority and the device priorities. Interface priority, the default one is 32768, and so the lower the priority, the higher the chance of being elected as the active link. So here, lower priority, or lower MAC address. Lower MAC address. So the same as to the actor. Lower priority. In case the priority are the same, we are going to use the lower MAC address. So that's all about it, guys. So also another rule for use to select the active interfaces is the interface number. You can also use the interface number. So the lower the interface number, the higher the preference of being selected as the active interface. So the lower the interface value, or the interface value, is the higher the preference of being selected as the active interface. Let's say maybe gig 1 and gig 2 both have the priority also of 100, and they are also gig 3 has a priority of 100, but now we will use now the lower the interface number, like gig 1 and gig 2 will act as the active because they have the lower interface numbers. So I think that's a good introduction, guys. Let me show you something also here. You can see how the active, how you can select the active. Like you say here, switch 1 here, gig 1, gig 2 act as the active. Then gig 3 and gig 4 are backup, like you can see here. So they say in LSP mode, maximum number of active interfaces can be configured when the number of member interfaces exceed the maximum number. The active interface, the interface with the higher priorities and smaller interface numbers are selected as the active, as we've just said. So let's see this one here. So initially, gig 1 and gig 2, they were the active interface. Now you see, now gig 2 has gone down. Now gig 3 will take over the role of gig 1 and forwards the LSCPDUs. So LSCPDU are the packets that are being exchanged between the two switches. So now let's jump into our configuration. That was a good theory part, and it was also help you understand now what we are going to configure in our practical here. So when we go back to the previous the practical, that the 2019 practical, this is the VLAN plan. This is the planning. So our interest is about just the Eth-Trunk. So the Eth-Trunk, we are told it will be forwarding VLAN 20 and 30. So and it is a trunk port. So that's where we are going to focus. Now you enter into your device. Once you are in your device, you undo the terminal to stop the disturbance while configuring your device. Then you change the device name. We are going to give you, this is switch 1. After changing the name, we are going to create the VLANs. That is, we have got VLAN 20 and VLAN 30. So VLAN batch 20 and 30. Then, like I said, we are going to give switch 1 a priority of 100, that is the device priority of 100 for it to act as the actor. Then we are going to give switch 2 priority of 200 for this to act as uh, the backup. So now we set the LSCP priority to 100. After that, we are going to create an Eth-Trunk interface. That's the Eth-Trunk interface. Also, we call it the link aggregation. That is the one that is going to bundle all the three interfaces into one logical interface. So we create an Eth-Trunk interface Eth-Trunk 1, and this Eth-Trunk is going to act as the trunk port to carry VLAN 20 and 30. So port link type, we're going to give it a trunk port. Then we tell it to allow VLAN 20 and 30. Port trunk allow pass VLAN 20 and 30. After that, we are going to configure the mode. We said we have two modes, the LSP and the manual mode. The manual mode, all the interfaces act as active interfaces, but in the LSP mode, we have got the active interface and the inactive one. So our mode here, we are told to use LSP static. Before we proceed, let's scroll down and see what uh, they required in the configuring link aggregation. So like you can see here, this is a link aggregation. So here is what they tell us. In order to ensure link reliability between switch 1 and switch 2, link aggregation is set up on switch 1 and switch 2. Switch 1 and switch 2 are connected to each other through gig 1, gig 2, and gig 3. These three interfaces are bundled into one logical interface, as I've just said. Switch 1 is the actor with the priority is the actor. Then we are told switch 2 priority is 200. So definitely switch 1 will give it a priority of 100 to show that the lower the priority, the higher the preference of being selected as the actor. Then the maximum available bandwidth number of the two devices is 2G, and the interface Gig 3 interface is a backup link. So in case one of the two other interfaces goes down, interface 3 should take over. So enable preemption and set the delay to 10 seconds. Then link aggregation. The links between switch 1 and switch 2 should realize load balance based on source and destination MAC address. So load balance, you can configure load balance in different modes. So we either source IP address, destination IP address, or source and destination IP address. Another one also is the source MAC address, destination MAC address, and source and the destination MAC address. So this one here, they've told us to configure it based on uh, source and the destination MAC address. So that's the practical we are going to do. So on this our switch, we've created our Eth-Trunk. Another thing we are going to do, also we've told it to allow pass VLAN 20 and 30. So we are going to load balance. So load balance SRC. So in SRC, you can be a distance mark, like we have told a destination mark, as the practical I've told as destination mark, or it can be a mark or source mark address, source IP address, source and destination IP address, as I've just said. So in this our case, they require us to configure it in source and destination MAC address. So that is what we are going to enter. After that, we are going to enable preemption mode. So LSCP preemption enable. Then we set the preemption mode to uh, 10 seconds. LSCP preemption delay to 10 seconds. Then we are going to configure the bandwidth of 2G. That is the maximum link number. We are going to set it to 2. So maximum active interface link number is 2. Then we quit. Let's so let's enter into that interface again and display what we configured on that Eth-Trunk. So we display what is on the Eth-Trunk, and we see here exactly what we've configured. We've enabled the interface and we allowed it to pass. Then the mode is LSCP. Then the next thing we are going to do is we are going to add the interfaces into the Eth-Trunk. So you quit. So enter interface gig 0/0/1. Then you add it to the Eth-Trunk 1. After adding to Eth-Trunk 1, you give it the interface priority. So LSCP priority over 100. Then you add also gig 2 to the Eth-Trunk. So say gig 2, add to Eth-Trunk 1. Then you give it a priority of 100. Then you enter gig 3. You add it to the Eth-Trunk. So because gig 3 is going to act as the backup link, now we are not going to give it the LSCP priority. It's going to use the default one, that is 32,768. So we are going to quit. Then we save our configurations. We enter the user view and we save our configurations. Say yes. And again, remember to save it on your device. Now we are going to go to our switch 2 here. On our switch 2, we do the same. So we do the same to our switch 2. We rename it. So this is switch 2. So we create the VLAN, the VLANs that are allowed to pass, VLAN batch 20, 30. Then after that, we create the LSCP priority to 200 because this one is going to act as the slave, as the other one acts as the actor. Now we create the Eth-Trunk interface, Eth-Trunk 1. The Eth-Trunk, we are going to create the link type. So in link aggregation, there are things that are supposed to be they are supposed to synchronize in when you are configuring the link. So these three things are like the link rate. Link rate should be the same. Another thing that should also be the same is the duplex mode. Duplex mode should be the same if it is using the half duplex or the full duplex. Both the interfaces of this device on actor and on the slave, they should be the same. If it is using half duplex, should be half duplex. If the link rate is 2G, should be 2G. Also, the VLAN configuration. VLAN configuration should also be the same. VLAN configuration, VLAN config should also be the same. Like let's say if it is an access port, all the interface should be accessed and you should configure the same default VLAN. If it is a trunk port or a hybrid port, you should configure the VLANs which are allowed to pass. They should all both be same on the actors interface and on the interface of the other switch on the other side. So we come here and Eth-Trunk, the port link type. We are going to port link type. This is a trunk port. So that's where we say the VLAN configuration should be able to synchronize on both sides of the interfaces. So port trunk allow pass VLAN 20 and 30. After that, we are going to configure the mode. So going to configure mode LSCP static. After that, we configure the link number, the active interfaces. So we configure the maximum active interface number to be 2. After that, we are going to configure preemption mode, preemption LSCP preemption enable. Then after that, configure preemption mode, LSCP preemption delay to reset it to 10 seconds. So then what remains now? What remains? So let's display this and see what we remain with. So we have got we've configured the Eth-Trunk. We've allowed it to pass VLAN 20 and 30. The LSP mode is LSP static. Preemption is enabled, and the maximum bandwidth is 2. And also the preemption delay we set to 10 seconds as the requirement of the practical. Now we are going to add the interfaces to Eth-Trunk. So you can add the interfaces to Eth-Trunk in two ways. Either while you are in the interface view or while you are in the Eth-Trunk view. On this other switch, on this side here, we added the Eth-Trunk on the interface view. Now we want to add it the the uh, the interfaces to the Eth-Trunk itself. Now we are on the Eth-Trunk view and we want to add the physical links to our Eth-Trunk. So while we are on Eth-Trunk 1, you trunk port, then gigabit, you add all the interfaces, so 0/0/1 to gig 3, 0/0/3. So display this. So we create and we save our configuration. So we save, say yes, and also save it on our device here. Now I think we have through with our experiment. Let's check. Let's check. So display Eth-Trunk 1. So it looked like Eth-Trunk 3 was not added. Eth-Trunk 3 is unselected. Okay. Interface Eth-Trunk. No interface gigabit 3 0/0/1/2/3 is this. So here you see gig 3 was not added into the Eth-Trunk. So Eth-Trunk 1. Okay. Now quit. Come on this other side, see if Eth-Trunk 3 is already on the interface on the Eth-Trunk interface G0/0/1. Sorry, we add it in the system view. Not /1, sorry, /3. So display and see if it's added on that Eth-Trunk. So it's on Eth-Trunk 1. Now let's check. Let's display our Eth-Trunk. All right, here as you can see here, you can see it here. So you see, this is what we've displayed. We've displayed Eth-Trunk 1. So we are in link aggregation group 1, preemption mode we set to 10, then the system priority was 100, active link number 1, least active link number, that is the one that is acting as the backup, it is 1, that is for gig 3, and the maximum active link number is 2. Then you can see it down here. Gig 1 and gig 2 are selected, so they are the ones which are active. Then gig 3 here, it is inactive, it is unselected. So you see here it's unselected, so means that it is inactive. In case one of the two interfaces goes down, gig 3 should take over. Then partner means that the switch on the other side. So the switch on the other side, we have given it a priority of 200, and you can see the MAC address there. Then it has all take the priority default one of 32,768. So switch 2 here, it should select the active interfaces based on the interface that has been selected by the actor. So all election is only done on the actor side, but on switch 2, it will select the active interface based on the interface that has been selected by switch 1. So let's come also to switch 2 and display the Eth-Trunk interface. I will quit and display Eth-Trunk, 1, and let's see. Also, you see the two interfaces has been selected based on the ones which were selected by the actor. Then gig 3 is now acting as the backup. So in case one of the others goes down. So while on switch 2, we are told that your partner is switch 1 with a priority over 100. So the port priority is set to 100, which are acting as the actor, and the port number is 2 and 3. Now let's try something here. I want to shut down one of the interface. That is, I want to shut down interface gig 2 to see if we shut down that interface, gig 3 will be able to take over the role of interface gig 2. So let's get to our device here. In your device, you enter interface view of gig 2, interface gig 0/0/2. Then you shut down that interface, shut down the interface. So display this. The interface is shut down, as you can see here. As you shut it down this side, also come and shut down on the other side. So interface gig 0/0/2. Then you shut down this. The interface has been shut down. Also, you can see it here indicated by the red, means that the interface is now down. Now let's come and display now the Eth-Trunk interface and see which interface has been now selected as the active interface, because we configured the bandwidth to be 2G. Now we quit and see the two interface that has been selected as active. So we display Eth-Trunk 1. When you display Eth-Trunk 1 here, you can see now it is gig 2 which has been unselected. Now it will not be forwarding the LSPDUs. But gig 3 gig 3 has now been selected. But even if its priority is still 32, but it has been selected to be forwarding traffic now, because gig 2 has gone down. So when gig 2 has gone down, the maximum interface should be 2. So gig 3 is now coming up to help in the role of gig 2 of the forwarding. So you see here, gig 1 and gig 3 has now been selected. And when you come to gig 2 here, the system priority has been to be 0, and also the MAC address, everything is 0. So also you come on this other side, on this other switch, and you quit. Then you display Eth-Trunk. The same thing should happen. Gig 3 should be selected as the active, then gig 1 also should be selected as active, because gig 2 was shut down, should be now unselected. That is just a scenario where maybe gig 2 has gone down, and the link, something has happened with the link and it has gone down. You should ensure reliability, means that the service forwarding should not stop. The device should continue forwarding traffic as usual, so that when gig gig 2 now picks up, it should now go back to its state of being active. Now let's take it back to active. So let's undo shutdown on that interface. So gig 2, then you undo shutdown, then display this. So our gig 2 is now active. Also, you undo shutdown on this other side. You enter interface gig 2, then you undo shutdown, display this. Yeah, so the interface has been brought up. So now let's now again display the Eth-Trunk and see. So when we display the Eth-Trunk now, you see gig 2 has now retained its original role. It is now selected as the active, and gig 3 has now gone back to the inactive state. It's the backup. It's act as the backup. It's the alternate. So it's act as the backup. You come also in this other switch, display Eth-Trunk, and gig 1 and gig 2 should be selected as the active, and gig 3 should be selected as the inactive. So that was all about it, guys, on link aggregation. This was very enjoyable topic, and I hope you understand every bit of the configuration that we've done here. So as always, I always say, remember to subscribe and also hit the bell, so that in case we load every video, you'll be able to get notification in your devices, maybe your phone or your laptop. So also you continue supporting the videos, and we publish for you more videos, and of your like, you can also request the videos that you may wish us to produce for you. So thank you guys, and continue supporting our production. So let's meet in our next chapters, where we are going to make sure we configure the all practical that I showed you here of that Huawei competition, and we are going to configure a full network. So follow every steps of our configurations, and you will be able to now merge all the configuration when you configure the OSPF, ISIS, and the BGPs. So till we meet in our next chapter, guys, uh, bye for now.